This video uses free-form motion as an example and introduces two main points. 1. The structure of MBDyn's input file. 2. How to interpret the kinematics file output by MBDyn. Let's see the basic workflow of MBDyn that's related to this example. The input file's name can have no suffix or any suffix. In the official PDF tutorial, there is no suffix. Many examples on the internet use the MBD as suffix. The file with suffix MOV is a kinematic data file generated by MBDyn, which includes position, orientation, velocity, and angular velocity data. Let's go ahead and see the input file. According to the instruction in the previous video, MBDyn made a relatively clear distinction between mathematics and physics. The structural nodes carry the position information of objects. The body carries the mass information of objects. Apply a force of gravity to the environment. There are many types of nodes in MBDyn. The commonly used type for studying dynamics and kinematics is structural. According to the syntax of MBDyn's input file, to organize the nodes and structure like this, the mosaic content in this picture will be explained later. The mosaic is added to prevent visual disturbance. It can be seen that the node's definition starts with begin nodes and end with end nodes. The structural node is defined between begin and end, starting with structural and ending with a semicolon. Structural node is commonly used in dynamics and kinematics analysis in MBDyn. Structural nodes is divided into three types. The type of structural node that can move is dynamic. The meaning of each part of structural node in this example is drawn in this picture. The numerical 1 after structural is the label of the node. It is self-explanatory that these are the spatial information of dynamic structural node, which belongs to the category of mathematics. The first parameter after body is the label of the body, followed by the label of a node, indicating that the body is associated by the node. That is, the node has the attributes defined by body. Gravity acts on the environment, and the mass objects in the simulation environment will be affected by gravity. The parameters related to gravity are very simple and can be seen at a glance. According to the summary of the last video, the mass and gravity belong to the category of physics, and MBDyn puts this into elements. In this example, elements is written as follows. According to the official MBDyn tutorial, the basic composition of input file in this example is data, problem, control data, nodes, elements. These file parts are written in order, but why does this video cover the last two first? The reason is, control data can be regarded as a brief summary of nodes and elements, while data and the problem are written in a relatively fixed way. When abstracting the simulation model, the most important thing is to figure out the nodes and elements. The rest are easy to write. The complete input file for this example is as follows. Let's go ahead and see the MOV file generated by MBDyn. MOV file is filled with numbers. These numbers are dynamic structural nodes kinematics data generated by MBDyn based on an input file. The data is divided into columns, and the meaning of each column is drawn in this picture. Let's take a look at the effect through matplotlib drawing. 3D position display. Two-D display of x, y, z positions with time t as the independent variable. Two-D display of x position with time t as the independent variable. 2D display of z position with time t as the independent variable. 2D display of z position with x position as the independent variable. Two-D display of velocity z with the velocity on the x direction as the independent variable. Two-D display of velocity z with time t as the independent variable. Two-D display of velocity at yz with time t as the independent variable. More plot methods is add here.